This year in SEAM, students from our class are mentoring the middle school students. The mentors are myself, Mason Lambert, Madison Sloan, Eric Smith, and Isaac Eli. We're focusing on the 8th graders, teaching them technology and chemicals. We're teaching them leadership and helping them to equip themselves with careers in the future. The projects that they are working on is building robots, synthesizing gold and silver nanoparticles, using new herbs available in our region that can be used as a detection method for cancer.
My name is Davlin Sherrill, and I'm working on the robotic arm project along with other 8th graders, Victoria Dotson, Maddie Bevins, Ty Hackney, Olivia Long, along with our mentor, Mason Lambert. Our inspiration.
Our initial idea was to create a remote control bowling ball, but after doing more research, we decided that it would be better to do something else. We then decided to build a robotic arm. Our end goal is to build a small wall out of wooden crafted blocks.
The coding.
Before we began building the robot, it was necessary that we learn how to code. We used an Arduino starter kit to educate ourselves on how to code. The kit included a DVD and also other materials to help us with our work. Then we started our first project, which was to patternize small LED lights.
Work in progress.
The picture to the right shows our robotic arm, and we are currently in the process of to check the functioning of the knobs that are connected for the operations for the robotic arm. And we have learned how to do many different things from this, and our Arduino DF robot kit will be writing codes to program the robotic arm. We perform operations like picking up objects and laying it in different ways and directions.
We will be creating a 3D printed robot. This robot will be made by me, Jackson Irwin, Brandon Harrison, Logan Thompson, Logan Maynard, and our mentor, Eric Smith. Our goals for this project: we will be making a 4-wheeled robot with the similarity of R2-D2 from Star Wars. This will be controlled using a Bluetooth module from our phone. This can be achieved by using the app Dabble. The code from the Arduino will communicate with the app via Bluetooth, which will make it move. We will be learning coding using the Arduino software.
The shell of the robot was built first, and it's shown in the picture to the right there. We used Tinkercad and made a model of the shell of the robot, and we sliced the file using Cura. The file was then transferred to the SD card to insert it to the Industry 3D printer to print the shell. The print of our shell took 27 hours, which was the longest print in the lab so far. The dimensions of the print it was 5 inches long, 5.25 inches tall, and 0.5 centimeter thick. We'll be using a kit of parts shown on the right, those 5 pictures, and more for our robot to move. The kit of parts includes an Arduino Uno R3, DC motors, male and female wires, breadboard jumpers, power supply module, a prototype expansion module, and an HC05 Bluetooth module, and more. At present, we're learning to code the Arduino to perform a few functions for our robot.
This is the robotic arm edge made by Bailey Dingus, Mackenzie Dotto, Lexa Hurley, myself, Lacey Hayes, and Robert Smith, and we were mentored by Joseph Eli.
The significance of our project. The significance of our project is to assemble a robotic arm edge by connecting different parts and connecting motors. Controllers are used to command the gripper to open and close, motion of the wrist to 120 degrees, extension elbow range of 300 degrees. Controllers can be used to rotate the base to 270 degrees and motion to 180. The edge can reach vertically and horizontally to 15 and 12.6 feet respectively to inch and place a 100-gram object.
This is the process of work that we carried out to build the robotic arm edge, and see our process from start to finish. You can also see the piece that we had to make.
We are planning to improve the robotic arm edge by providing wheels to the base using a motor so they can be moved to different places. We are working on to increase the size of the arm by 3D printing extension so the arm can be extended to pick or place things at further distances.
The
Nanoparticles Project 2021 to 2022 by the following eighth graders: Rayleigh Johnson, Heather Hatfield, Marielle Restar, Darby Thompson, Kendall Starr, and Meredith Justice, and our mentor at Madison Sloan. Overall goal.
Our overall goal is to be able to use many plant extracts to cap gold and silver nanoparticles. Capping is what stabilizes nanoparticles and inhibits overgrowth. We were able to test kudzu, sunflower, zucchini, and tomato, also bittermelon. However, we were only able to test the first four for both gold and silver nanoparticles. On the right, there's pictures that shows the final solution of gold and silver nanoparticles.
Recorded UV spectrum.
This recorded UV spectrum shows the absorbance at 410 nanometers and 520 nanometers. This provides confirmation about synthesis of gold and silver nanoparticles.
Our future goals are to help the environment by taking on invasive plants and using nanoparticles to cap them. We would also like to use nanoparticles to identify cancer cells in the body. Gold and silver nanoparticles can be used to cap many different extracts that we create.